Welcome to the ET322 how-to video for our Lab 1 using the oscilloscope with Multisim. Here I am in Multisim, my copy on my computer. You could do this also in VMware, which I'll show you in a different video. So let's go ahead and get started. So let's open up our lab. And we need a triangular waveform. So let's go ahead and copy and paste this, enable editing. And let's go ahead and copy that. And let's go ahead and paste it. Okay, so we're looking for a triangular waveform. So first thing we're going to need is a ground. And that is going to be under sources, power sources, and we're looking for a ground. And let's go ahead and we're going to grab a DMM. I don't think we're going to use it. And we need a function generator. And we're going to go all the way down here, and we're going to use a Tektronix oscilloscope, which is the same one that we use in the classroom. And let's see if no. So let's go ahead and pass around our ground here. So let's copy it. And we're going to paste it here. We're going to paste it in the middle of our function generator. So we could push it up till we get a red dot, and then we could pull it down. Or we could go click, drag, click, and we make our wire. Okay, so let's go to view and let's zoom in. And let's do better than that. Let's go to view and let's zoom area. So let's see if we can get this thing where you can see it. There you go, it's better. Okay, so we're going to take our positive output of our function generator and we're going to go into channel 1. And I could take this guy and I could drag it down. And I could take this wire and I could change it. We could go to segment color and I could just pick something from our color wheel and let's make it blue. No reason, but we could change the colors that way. Alright, so let's go ahead, since we have our grounds and it looks like we're okay, let's get rid of our ground. Just click on it and delete. We'll use our DMM later. Let's go ahead and move that over here on top, and let's go ahead and zoom out again. There we go, nice and big. So let's go ahead, first thing we have to do is go ahead and click on this triangle run. Okay, or you could go to, let's see, file, nope, edit. Well, we're going to go right off the front here because I can't find it right now. Okay, so now we're running. Let's double click on our oscilloscope and we're going to bring it up, and it looks just like our scopes in the lab. Alright, so we need to turn power on. Okay, and let's go ahead and set our function generator. And we need 6.3 kilohertz. So let's go to in the drop down menu kilohertz. 6.3, and 50% duty cycle is fine. And actually, since this is peak, we're going to make it 5. That would be peak. Okay, oh, it says 5 volts peak. But we could also change that to peak. Okay, so we're just going to leave this at 5 volts peak. But actually, we need 2.4, sorry. 4.4. Just click on our drawing and get this out of the way. And in order to dial this thing any scope, we're going to, first thing we need to do is volts per division. Well, that's 1 volt per division. It fits in the screen. Let's just leave it. Okay, now we need to change our time scale so that we can get a good picture, because you don't want to be drawing more than we need to. Actually, that looks pretty good. And let's go ahead and go to triangular wave like we're supposed to. And that may need to change. Oops, do it here, sorry. There we go. Okay, so now that we have this up, let's go ahead and go to single sequence. Okay, and that'll lock it in where we can make a picture of it. So let's go ahead, if we want to change the position, which I want to, is right there. Okay. And let's see here, this is the 0 line. This is part of the trigger. This is also the trigger. Okay. So let's just move the trigger. So let's go to trigger menu. Channel 1, so we're good. So if we got channel 2, channel 3, channel 4, let's go back to channel 1. It's yellow, and we can move that arrow up and down. In order to lock this in, we want the arrow touching the waveform. Okay, so let's fire it back up again. There we go. And there's a couple ways we can measure this. Okay, first one is probably, we just go to measure, all channel 1. So let's do frequency. That's good. So let's go to back. Go to the next one, and let's say we want peak to peak. So let's peak to peak, back, and it's 4.2. We'll go ahead and clean that up a little bit. That's a little short. And let's do period. Wait a minute, let's go to here. Okay, peak to peak, frequency. Let's go to period. Okay, back. Okay, so the period is located from one waveform to the next. Okay, and any part of that waveform to the next one. So that would be the period. If you take the inverse of that, you'll get the frequency. Okay, and peak to peak will be from this bottom all the way to the top. Peak would be from the midline to the bottom, or midline to the top. Okay, so that's our triangular waveform with the specs. So what we want to do in order to put this into our lab, we're going to utilize the snippet tool, and it should be part of the Windows package. Just put new, and we're going to go ahead and just cut this out and copy it, and then we're going to paste that into the Word document, and you're going to save yourself some time drawing it. Okay, let's close out of that, and let's do the okay, let's do our next waveform. Let's get rid of this because it's not correct. Well, it doesn't want to behave, so we'll just move it out of the way. Okay, so let's turn it off and go back to our function generator. The next one's going to be a sine wave. So we're going to go to the sine wave. We're going to go back to our lab. And our sine wave is 3.7 kilohertz. So this is 3.7 kilohertz, and we have 4.3 volts RMS. Okay, so Let's see if we have RMS here. Peak. No. So let's go. This is peak and want RMS. So we're going to have to do some adjustments here. So we're just going to go ahead and make this peak for now. Okay. And it is 4.3. And we could do the formula, but we're not going to do that now. Okay. Yeah, close enough for now. Let's start it up. Move that out of the way. And we need to, let's add another one here. We're going to add RMS. Okay. And we're going to have to, we got running. So let's go back and let's run stop. And again, let's bring it up 2 volts. Move out our display. Come on. There you go. And let's see what if it'll calculate again for us. There wasn't enough there to measure. And we have 3.07. And we needed 4 point something. 4.3. Alrighty, so we've got 3. Okay, we got to go some more. So let's go ahead. Let's try 5.2. Without doing the calculation on it. So we're going to have to take it off, turn it on, and we got 3.6 RMS. Okay. RMS is the average of this waveform. A little more complicated than that, but that's pretty much it. It's the area under the curve. Off, on, let it recalculate, and we've got 4.2. That's pretty close to 4.3. I'm going to say that's good. So let's spread this out and just get a couple waveforms on it. There you go. Let's bring it back over. Single sign. And we have our waveform. And the last waveforms we're going to do is rectangular waves. So let's figure out what we need. And 10,000 hertz at 8 peak to peak. Okay. Oop, and 70% duty cycle. That's a hard one. Okay. So we're going to do rectangular. We're going to turn it off. We're going to do rectangular. 10 kilohertz. Okay. And we're going to duty cycle, which was let's see what that was. Duty cycle 70%. So let's put 70% into our duty cycle. Okay, that means it's going to be 70% high and 30% low. So let's start it up again, and good. So now we have it. So let's get it on here. We won't draw the picture like this, but we'll go ahead and check it out. So peak to peak, we're not interested in that. So let's go ahead. We're going to go time high. Positive width. Okay, that'll work. Back. And let's go negative. Let's leave that one alone. Let's go with period, and we have, let's go ahead, negative width. Okay. So hopefully you can see this, that we have 100 microseconds period, which means it goes from beginning to end. Okay. And so we have a negative width, which is the downside. So we have 30 microseconds low, And we have 70 microseconds high. 70 plus 30 is 100. So that is a 70% waveform. And let's go ahead, there you go. So let's go ahead and use cursors. Probably got to turn it off and on. Use cursors. And we're going to go on voltage. And next is time. Okay. And you see the green lights here underneath these. So let's move our cursor over. There you go. Well, kind of. The real ones work a little better. But anyway, that's close. Let's move the other cursor. Come on, come on. There you go. 29.2. That's really close to the 30, isn't it? So let's go ahead and move this one, and we might get a weird number because I'm doing them backwards, but let's see what happens. And time high is about 70. And let's move this guy back over, and our total width is 16. Yeah, I got it. Let's go ahead and delta is 96 microseconds. Good. It says minus because I got the cursors backwards, but that's close to 100 microseconds. And that's what we wanted.